Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Okay, so today I'm going to explain about the pre-lab experiment 2. Okay, so at the end of the lesson, you should be able to define the molarity and standard solution, to state the use of the standard solution, to describe the preparation of a standard solution of the oxalic acid, to differentiate between the endpoint and equivalence point, to explain the precautions required during the titration, and the last one, to calculate the concentration of HCl solution in an acid-base titration. Okay, so this is the question regarding to the pre-lab question. Okay, so first question, so you have to know about the define the molarity. So what is the molarity? So this one you have been discussed in your tutorial class, right? So molarity is the numbers of moles of solute per liter of solution. So this is one term that you have to understand and you have to be familiar with. Okay, so the unit for molarity, it should be mole per dm cubed, or it can be mole per liter, or it can be capital M. Okay, so what is the standard solution? So the standard solution, is a solution of accurately known concentration of an element or a substance. Okay, so this we call as a known concentration. We call as for standard solution. So state the use of the standard solution. So apa dia punya use atau kegunaan standard solution ni? Okay, so a standard solution is used to determine the concentration, which is we call as a molarity of the other substance such as solution in titration. So basically, when we use the standard solution, so this one will involve of the titration. Okay, so you have to know how to prepare the standard solution using the volumetric flask. Okay, so we go for further for the next question. Okay, I will discuss a bit more about the standard solution. Okay, so what's the difference between the endpoint and equivalence point? So the endpoint, it means that the point at which the indicator change the color. Okay, means that, for example, if you have the phenolphthalein indicator, so what the color change? So the color change for phenolphthalein is become from the colorless to the pale pink. Okay, so that one, when the color change from colorless to the pale pink, so that one we call as an endpoint. Okay, so they have a many indicator you can use. For example, methyl orange, methyl red, bromine, tiny blue. Okay, there's also many. You can search in the Google. Okay. So what's the equivalence point? So equivalence point means that the point at which the exact reaction occurs between the two reagents according to stoichiometry. Okay, for example, if you have the HCl plus NaOH, so you can produce the salt, which is NaCl plus H2O. Okay, now you have to know what's the stoichiometry that involved for HCl and NaOH. Is 1 to refer to 1. Okay, the exact reaction. So when this occur as this at the exact using the stoichiometry, so this one we call as the equivalence point, which means that NOH minus equals to NH plus. Okay, the number of mole of OH minus equivalence with number mole of H plus. Okay, so in this case we call as equivalence point. So it depends to the equation yang kita pakai ataupun jenis kind of strong acid or strong base, or weak acid or weak base. Okay. Okay, so that's the procedure in this question. So you have to know, state the 3 precautions, that must be taken during titration to ensure the accuracy of results. State a reason for each precaution. Okay, basically for this kind of precaution, so this you have to state. Okay, you have to state in order for you, okay, to know the accuracy of the result. Okay, basically for the titration. So first thing what you have to know is, okay, first precaution is to ensure the accuracy of burette reading. So you have to know that you have to take the bottom of the meniscus. Okay, bottom of the meniscus, okay, that aligns with the calibration mark at eye level as the reading. Okay, so you can see here, this is the burette reading. So this is a 32. Okay, kita baca dia. Okay, 32. Kat sini bawah 33. Okay, when you look at to the, okay, use this is your eyes, right? So when you eyes, it must be parallel, okay, to the bottom of the meniscus, means that you have can see here the line. Okay, this is a line of the solution. So means that the meniscus is a mass from here. Okay, from here until you can see is a half here. Okay, so when you baca this reading from the burette reading, kita akan baca daripada atas. Okay, from the up, it's not from the bottom. Okay, this is given for you. Okay, 32. Okay, the burette reading you have to know is, it give two decimal places. Okay, for example, if you have 32, so 32.00. Okay, so here you have to look at the eyes must be parallel from here. So 32, 32.1, 32.2, 3, 4, 5. Okey, yang tengah ni jadi maksudnya 32.50. Okey, di antara this sengatan, actually dia have the separuh daripadanya adalah, contohnya ini 32, kalau separuh daripada dia 32, yang ini 3.40. Kalau dia duduk level tengah ini, so means that you kena baca dia adalah 32, 31, 32, 32.5. Okay, 32 point, sorry, 32.1, 32.2, 32.25. Okay, so tengah-tengah ini is we call as half. Okay, so separuh daripada dia 32.25. Okay, 32.3, 4, 32.50. Okay, sampailah bawah dia. So means that you have here the sengatan here. Okay, you have the bottom of the meniscus. Okay, with the, we call it a calibration mark. Okay, this one we call as the calibration mark. Okay, so next step what you have to know is, okay, so in order for you to get the accurate reading, okay, so make sure you ensure there's no air bubbles in the burette tip. Okay, there has no air bubbles in the burette tip. Okay, because this is because the presence of air bubbles will affect the volume of the titrant used in the titration. If you can see here, this is the burette. Okay, this is a stopcock. Okay, we call a stopcock. This is the tip. Okay, so when you rinse the burette, first with the distilled water, okay, you rinse is one first, and then second you have to rinse with the solution that we want to fulfill here. Okay, for example, you want to full an AOH, so make sure you masukkan dia dalam ni, make sure this one tip ni mesti penuhkan dengan NaOH. Okay, dia jangan bagi ada ni air bubbles. Kalau ada air bubbles, the precaution dia you kena tap. Okay, you kena macam tap dia banyak kali, 2 kali ke. Then you akan kena tengok air ni supaya dia tak ada bubbles kat sini. Okay, kalau ada bubbles, dia akan menyebabkan you punya accuracy ni tak tepat lah. Okay, you punya titration is not accurate. So make sure there has no bubble at the burette tip, in the burette tip. So this is very important, okay, for the titration. Okay, make sure dia punya NOH when you lalukan ni, you buka stopcock ni dan you penuhkan NOH dia sampai dalam ni, penuhkan, baru you tutup. Okay, yang ni you letak beaker lah dalam ni. You letak beaker, bila dia alihkan dulu, baru you tutup stopcock ni. Kalau keadaan macam ni, dia maksudnya dia open. Okay, kalau you buat dia macam ni, okay, horizontal, dia akan jadi close lah. Okay. So the next one, okay, so okay, when upon reaching, okay, reaching the end point, so titrate slowly until the pale pink color remain for more than 30 seconds. So the reason is to ensure the accurate bill rate reading is recorded at the end point. Okay. So you can see here, this is for example, if you do the starting point, okay. Okay, then the second we go for the slow down, the color become like here. You can see pale pink. We use the um, phenolphthalein as our indicator, and then you can see here the end point is become like pale pink. Okay, next I will show you the real pink picture. Okay, kalau dia terlebih, so dia ada overshot. So yang ni dah terlebih over end point ni, tak bagus lah. Okay, make sure when you titrate slowly. Okay, first drop pun dia dah memang bagi beza dengan even you drop with a 2 drop. Okay, even the first drop pun you have to make sure you get the pale pink color. Okay, pale pink color remain after more than 30 second. Maksudnya you kena swirl dia. Lepas dah dapat endpoint tu, you swirl dia sampai 30 second. Kalau color dia tak berubah, okay, maksudnya itu you punya endpoint lah. Okay, nanti you akan tengok you punya recorded video supaya lagi nampak lah. Okay. So briefly describe, okay, for this question, actually this is for you to prepare, describe how to prepare 250 ml standard solution of hydrated oxalic acid with a concentration of 0.25 molar. Okay, so the question asks you to describe how to prepare 250 ml of standard solution. Okay, first thing what you have to do is you have the concentration. Okay, the question given here. Okay, 0.25 molar, just refer the molarity, and then you kena tahu dia kena pakai yang dia punya standard solution dalam volumetric flask dia mesti 250. Okay, so you boleh buat. Okay, first thing you cari dia punya number of mole. Okay, number of mole of oxalic acid. Okay, what means of hydrated? Maksudnya dia surrounded by 2 mole of H2O. Okay, so you know the formula of N is equals to MV. So M refer to molarity, 0.25. Okay, you can take it from here. So volume, it must be changed, ataupun you kena tahu volume must always in liter. So you have here 250 ml, then you convert to liter, which is you times 10 to the power of negative 3 liter. Okay, so bear in mind, so this one is N is equals to MV. So you find the number of mole. Okay, ada certain student dia buat N equals to MV over 1000. Okay, tak ada masalah. Tapi you kena tahu kenapa kita bahagi 1000, sebab kita nak tukarkan dia kepada liter. So basically is the formula dia like this lah. N is equals to MV. Okay, so mole is equals to 6.25 times 10 to the power of negative 2 mole. Okay, so next step what you have to do is, okay, so you nak cari dia punya berapa mass of oxalic acid yang perlu dilarutkan, yang kita perlu timbang, which is you ada formula mole, okay, times with molar mass. So mole here, so you get, okay, yang you dah calculate, so you masukkan dalam sini. And you have to know the molar mass of hydrated oxalic acid is 126 gram per mole. So how I can get this? Okay, so basically you have to know when this dot, okay, means that you have to sign dia sebenarnya kena tambah. Okay, carbon you ada 12 times 2. Okay, so you have the hydrogen 2. Okay, oxygen is 16 times 4. Okay, this one, okay, you add with, okay, 2H2O. So 2, okay, means that you tambah, the signs is referred to tambah, plus 2H2O, 2, hydrogen is 2, oxygen is 16. Okay, oxygen is 2 plus 16. 2 plus 16, Okay, is 18, 18 times 2. Okay, then you tambahlah. The total means sign here, dot here means that you have to add. Okay, bukan kena darab So then when you add this one, you can get this total is 126 gram per mole. And then you times with this, then you get mass there. Okay, now baru you